Hello, everyone, and thank you for attending part one of our two-part webinar series, A Java Renaissance. Before we begin, I'd like to cover 3 housekeeping items for our viewers. First, at the bottom of your audience console, you'll find a number of widgets for questions, slides, and additional resources. When you have questions for the presenter during the webcast, click on the Q&A widget and submit your question. We will answer as many questions as possible at the end of the webcast, and if we run out of time, we'll get back to you via email. Additionally, there's a short survey in the console to the right that we would like to get your input on. Second, a copy of today's slide deck will be available in the resources folder at the bottom of your screen. Third and finally, if you need any tech support during the webinar, please use the help option. With that, I'll introduce our presenters for today's broadcast. Justin Riak, Open Source Evangelist and Chief Architect at Open Logic by Perforce, and Michael Rasmussen, Java Evangelist and Product Manager at JRebel by Perforce. Justin and Michael, thanks for joining us on today's broadcast.
Thanks so much, Stephanie. So today we are going to discuss sort of how we've gotten to where we are today and a lot of the new activity that we're seeing in the Java community, and sort of end with some words around what we're seeing around the release of JDK 14. So let's just kind of recap a little bit on a brief history of Java. For a lot of you, this may be a bit of review. But Java is a general purpose and cross-platform language that was developed by James Gosling at Sun Microsystems back in the mid-90s at this point. All right, so it has been around for a long time. It's absolutely fair to consider the notion of a Java veteran at this point. It solved a number of problems at the time. I'd say the biggest one probably being portability, but also simplified memory management and a general sort of abstraction or separation of the language from the operating system. So C being the dominant language at the time, we had some deployment concerns and issues sometimes with C where C needs to be compiled or built on an architecture and platform that it was intended to run on, and is often tightly coupled to dependencies living at the operating system level or layer, which can make deployment difficult, which can increase time to create builds, and also sort of force, I think, a certain amount of operating system knowledge and concern onto developers that doesn't really belong there. And so Java came along to help us with some of these things. So instead of being tied to dependencies within an operating system, it's instead abstracted from the operating system and runs inside of its own virtual machine. Instead of forcing the developer to think about memory concerns and allocation and deallocation of memory, garbage collection and things like that, Java manages a lot of these for the developer, allows the developer again to kind of focus on their own code. And these changes made this language wildly popular across enterprises, independent software vendors, and of course open source communities as well. And it's really not just the cross-platform nature of Java that made it so popular and gave it such a wide footprint. I think the cross-platform nature is very important, but I think that Java as a whole did a very good job developing standards that were easy to understand and share across large development groups. So I think from both a language, syntax, and a process and architecture layer, it made sense as a language that was just going to work for big enterprises. But that would extend to open source communities because often we have many, many developers working on those projects as well. Right now, it's actually the third most popular programming language, according to the GitHub State of the Octaverse. These are just statistics that we'll look at in a second. They come from GitHub. This slide actually doesn't need to be updated, but again, depending on who you ask, Java tends to fall into one of the top 3 slots. It's a very, very popular language. And it was acquired by Oracle in January of 2010. Which in turn would lead to a fairly controversial series of forks and some lawsuits and general disruptions, and ultimately would produce what we now know as the Oracle JDK. So again, coming back to the state of the Octaverse statistics. By the way, if you're not familiar with this report, it's a pretty great report, especially if you're interested in consuming open source software or looking at information on adoption of open source software. This takes just sort of raw statistics from various software repositories within GitHub and pulls just data out of them, which for anybody who's tried to get these types of statistics, particularly around open source projects and open source adoption rates, we know that it's notoriously difficult to get that data, kind of by intention, right? Nobody's really tracking who's pulling software from public repositories and standing it up internally and using it and whatnot. And I don't think that we even necessarily want that to be tracked. But to get close to some of that data, the State of the Octaverse is an excellent report. And it did bump the Java language down to number 3, but again, I do want to point out that that's just what's visible to GitHub. We're not talking about code that may be proprietary, living within an enterprise or business or something that may be in a different type of source code repository. The language itself can be found anywhere today. I mean, it's on my phone, probably a lot of your phones and tablets too. We see it still powering a large number of web applications. We're seeing it move to IoT and embedded devices. We have a number of customers who are actually using this for using Java in various banking applications and things like ATMs and kiosk software, whatnot, gaming devices, set-top boxes. So, again, it's fair to say that Java really is pretty much everywhere at this point. So a lot of footprint, over 30 years old. It's a mature syntax. Very, very widespread, well-adopted language, which I'm sure should surprise very few people on this webinar. Going through sort of a history of Java here, we're not going to talk through, all of the detail of these milestones, but, I think that a few of these are notable. We, of course, see, the first JDK release in 1996, so sort of the mid-90s, followed by the JEE release, the Enterprise edition of Java coming in 2006. The 5th edition of Java Enterprise coming in 2006. But we see that there's this immediate attention to the enterprise, right? Now, Java EE being, of course, a standard and set of Java standards that make sense for solving enterprise class problems with Java. But we see this focus on the enterprise very, very early. And then, a bit over 10 years after its initial release, we do see the first release of OpenJDK. And we see this coming during a time, where Java release 7 has been imminent. And so it's important to point out then this is one of those pieces where when we talk about OpenJDK's functionality and is it upstream from Java that's being built now and being used now, this is an important milestone to remember. Java before OpenJDK, we can't give the same type of, comfort as we can with modern, post 1.7 releases of OpenJDK, because we know that the development of OpenJDK was not always upstream from Java as it is now. So it's important to remember that milestone. We see Android released in 2008. Java had already taken a very good foothold in the enterprise and in the type of applications that were popular at that time. And now we see it move to mobile applications, which, as we all know, proliferated well beyond any of the standard business class applications that we've been running. We now have millions and billions of apps and devices and everything running everywhere. And then, of course, the Oracle acquisition of Sun in 2010. And so, again, with a lot of this footprint, we shouldn't be too terribly surprised by some of these statistics that we see here. A lot of, but what's interesting more recently has been this movement towards the upstream OpenJDK builds of Java. I think that it's completely fair to say that some of the license changes back in early 2019 around LTS Java and Java 8 have motivated some of this shift. I think some of it also is just the move towards open development as a whole that the industry's taken. But the long and short of it is that right now we're seeing about a little bit less than half of our Java projects, according to survey data, being built on open source or open JDK built, or JDKs, whereas a majority are still being built on Oracle. But what we expect is that by 2023, according to predictions by Gartner in a recent white paper report that they've listed, where we've cited in a couple of our blogs, we expect to see 80% of these projects on OpenJDK. So that we are in the middle of a massive industry shift right now, and that is forming a lot of the narrative. And I think when we look at this survey data and we compare it to some of the other languages that are being used just sort of in the wild, now of course this is a JRebel survey across Java users, but we see that we've actually moved to an important epoch where a large amount of the industry has embraced Java 8. But of course, as we know, Java 8 has moved into LTS with Oracle, and Java may be sort of notoriously difficult to upgrade in these older versions, which is why the impacts of these license changes are actually being felt, despite them just being sort of typical policy. So again, sort of a look at where Java started, some of the more disruptive shifts in the Java timeline to kind of set a stage for where we are now and how we've reached this sort of Java renaissance that we're finding ourselves in. And so with that, I'm going to turn the discussion over to Michael and let him talk about some of the activity that we're seeing with Java now and some trends that we're seeing.
Well, thank you very much, Justin. Yeah, if we are trying to look at some of the things that have happened in Java, well, since Java 8 for that matter, like Java 8, as we saw on the nice little graphic Justin had with the snake, I will call it, Java 8 was released in 2014, and it was a major release back then. And then, if we look at it, like Java, the first Java version was in 1996, and then we had basically, we had 8 major versions until 2014, and now later this month we will have Java 14. So since basically since the release of Java 9, we changed to a different cadence where we have a new major release every 6 months instead. So that's a huge shift in how Java is released, how Java is developed, how the JDK is developed. So looking at this nice graphic we have, as you can see, Java 8 in 2014, then Java 9 in September 2017, and then 10, 11, 12, 13, which was released here last fall, which is the current released version. And then, of course, we have Java 14, as I mentioned, coming up now in, well, basically next week, actually, already. So it's very, very soon. So what does this change in the cadence of releases actually mean for Java? Well, if you look at JEPs, which is one of the is the JDK enhancement proposals. Then it looks a lot like this. Like previously, we had like these huge badges. We don't really see it here. We can see at the end of 2017, we have all those. We have a huge list of 53 finishing just for Java 9, because this is when Java 9 was released. Other than that, they were not spread out as we see following it. The following years, because, well, they knew that Java 19 was originally supposed to be released in 2016, which is why we see a lot of them actually finishing like a few months earlier. These blocks are, by the way, 6 month periods. But instead of them being clumped up for these major releases every 3, 4, 5 years, as it was in the past, they changed from Java 10 and on to do 2 releases per year, and then with the idea that we'll release whatever features are ready. In this list, we're just listing the JEPs, which is some of the features that receive most of the things we talk about in Java. But of course, other things are happening not just in JEPs, but let's just look at the JEPs for now, because they are they're easy to see that these are usually major things that are going into to the Java. If you look at, for instance, if we cram it a bit more together, we can see that we have like these 56 to JEPs finishing in the period of 2011 to 2014, because this is more for Java 8. Then we have the Java 9, which is like 91 of them. And then over the next few years, we have about the same amount of JEPs being finished, and also how many we projected being finished within the next 1.5, 2 years as well. We have the same amount of work being finished in terms of JEPs, but instead of having them come all in one batch every 3-4 years, they are spread out and being released whenever ready. So if you go and look at JDK 9, so JDK 9 has about 90 JEPs. I've just listed a subset of them here, some of the bigger ones that had a huge impact on both Java and also the future of Java and both of the languages as a platform. We saw also the things that the biggest thing here, of course, was the module system, or the way that they changed the entire JDK to be modular, which set a precedence for how all future things were in the terms of Java. Now, the funny thing is, as Justin also mentioned, that Java 8 was an LTS, or long-term support. Many people were expecting that Java 9 would be the next long-term support, because that was kind of how it worked. Every new major version of Java was a long-term support release. But when Java 9 came, suddenly it was no longer a long-term support, because the first long-term support under the new release cadence would be JDK 11, which wouldn't come until a year after. So JDK 9 was this kind of like limbo release. It's not fair to call it a limbo release, but many people didn't really know what to do with it, because should they stick with LTS versions? Should they try out the newest, or what should they do? How was JDK 9 going to be supported? Because do you want to run something in your production that's not supported for long? Also, given also what Justin mentioned, that the upgrade process from major version of Java to the next major version of Java hasn't always been painless. There are sometimes some bigger, sometimes some just smaller issues doing so. So JDK 9 ended up in sort of this state where it was like a huge release in terms of number of features and what went into both the JVM and all the tools around it, but no one ended up really using it, because they were kind of waiting for what was going to happen in the future with Java. Java 9 was still had a lot of, or still does, it still had a lot of things that has affected the future of Java. I mentioned the module system, which was probably the number one thing. It was also what ended up postponing Java 9 for an additional 6 months. It was supposed to be released in the beginning of 2018 and ended up being released in September instead, because the last 6 months was basically just changing how the module system worked and making sure that it was up to how the community, because this was really, the module system was one of the most highly discussed items in Java 9. And there was a huge community interaction on how it should work, both regards to syntax, but also on how it should work on a JVM level. And they kept updating it and improving it all throughout the spring and summer until they finalized it around July that year. But from a more ops point of view, one of the biggest changes here, not just the module system, was also that suddenly the G1GC became the default garbage collector. Previously it was introduced already like in almost 10 years, like 5-6 years earlier. I think it was in Java 7. It was introduced for the first time, and has kind of been there, but so you could switch to it if you wanted to use it, but it hasn't been the default. With Java 9, it became the default GC, which for production systems where people are usually fine-tuning how the GC works and everything, this was a huge change. Some other things for developers, you suddenly saw a REPL, like a read-eval print loop, like in the J shell that was added. You saw some changes, minor changes, not directly on language level, but in the API supporting language, for instance, the way string concatenation works, when you just do like string plus int plus string kind of things in your source code. Previously, the compiler would compile that down to a string builder. Now we're suddenly using some factory methods that, together with the invoke INDI, or invoke dynamic, it would concatenate together. Invoke dynamic is the technology used also with lambda. Previously, it's only been used with lambdas in Java 8, but now it's more and more used. Actually, it's kind of become one of the go-to technologies on the bytecode level that the Java language engineers are using. You will see it used in many of the newer proposals or things that have been updates to the language as well. So Java 9 also added a ahead-of-time compilation, at the time only in limited form on Linux platforms, and it also added the Java-level JVM compiler interface, which basically, for those of you that are familiar with Graal VM or Graal, this is basically it basically was the option to enable a JIT compiler written in Java to use as the JIT compiler for the entire JVM. For those of you not familiar with JIT is the just-in-time compiler that takes basically your class files when they're loaded into the JVM and converts it into the machine code that is native to whatever system you're running on, which is why Java can use the same bytecode on every single platform, because the JIT compiler will compile it at runtime into whatever native code your machine you're running on, be that on a Intel platform on Mac or Windows or Linux, or even if you're running on AIX or a Spark, you will have JIT compilers for that. So your Java code is run as fast as possible in these environments. So Java 9 was a big release in that sense. But as mentioned, it was kind of in this limbo state. So if you can move forward to Java 10, suddenly we see this was released in March 2018, meaning just 6 months after Java 9. So you see where Java 9 had these 90 plus JEPs. Suddenly Java 10 only has about 10 to 15. So it's a lot smaller in scope. But then again, you suddenly have the ability to push things a lot quicker, which was the whole idea with this new cadence. Develop things fast, or develop things and get them out there as fast as possible. You can see actually the JEP 3.2.2, the time-based release versioning, is basically this new release cadence clarified into a single JEP. How this basically described that, hey, we are going to release every September or every March, and we're just going to release what's ready. So they have these terms of the ramp down phases, which means that, hey, by this date, anything that should go into this release has to be ready by then, and then it get merged into the source gets branched out from the main development tree, and then the changes get tested and fully supported and goes through a release candidate phase, basically like any normal software release process. So some of the main features that Java 10 had was, of course, the new version of time-based release versioning, or like these release cadence. We had the extension of the Java-based JIT compiler here, which is so you can actually use it as well. Previously, it was only used for the ahead-of-time compilation in Java 9. But now there was actually a switch in the JVM, so you could say that, hey, I want to use this Java compiler instead of using the one that's natively written inside the JVM, basically in C or C++. Some of the other major things for the JDK 10 was, of course, the introduction, or on the language level, was the introduction of the var local variable type inference, meaning you can use var instead of writing out the entire type for variables within a method. Another important thing here is that basically it's a building block for future versions was the garbage collector interface. And the reason for that, or the reason why this is a building block, is that since the release of Java 10, there's actually been 3 additional garbage collectors added to the JDK, to OpenJDK. And they all are available because this garbage collector interface was added in JDK 10. That meant that these garbage collectors could be added a lot more easily than they were previously, where they were kind of intertwined in every single JIT compilation and every single other part of the OpenJDK. This garbage collector interface added a clear interface for how the garbage collector interacts with the system. So if you go to Java 11, which was a huge release in the sense that it was the first long-term supported release. That being said, long-term support doesn't actually mean that every single Java 11 version out there is long-term support, because the long-term support was actually just Oracle's invention at the time. With the new release cadence, from the open JDK point of view, every single release had a support window of 6 months, meaning until the next major version was out. And if you wanted support outside of that, then you needed to basically buy your support from one of the many vendors out there. Oracle themselves then said that they were going to support, have certain releases that were long-term supports. Java 8 was the existing one at the time. Java 11, or JDK 11, would be the first one with long-term support. Then JDK 17, which is supposed to come out in a year and a half, is going to be the next one. So basically every 6th release is a long-term support release. Now, since Oracle basically dictated that, hey, these are the versions that we are going to support, most other vendors out there that are releasing Java and supporting Java has followed suit and also declared that, okay, JDK 11 is also an LTS from our point of view. And when the 6-month window was up and OpenJDK stopped officially supporting it, Red Hat actually took over the stewardship of supporting the upstream version of OpenJDK that most of all the vendors are using today to build the JDK 11 from. But as for features that JDK 11 added, well, one of the big things was actually the flight recorder. Flight recorder was previously a commercial feature in the Oracle JDK that was then donated to the OpenJDK project, and now with JDK 11 became available for everything. The flight recorder is basically a way to monitor what's going on inside a production tool that you can use to monitor what goes on inside your running JVM. So it's very powerful in that, and I know that many use it out there in their production system to figure out what's going on and basically get sort of more like APM level of details and statistics about the running and health about the running JVM. You can also see here, if you look at this list, there's the first garbage collector, the new interface, which is the Epsilon garbage collector or the no-op garbage collector. As the name suggests, this garbage collector actually doesn't do anything. This is basically a garbage collector that doesn't do any garbage collecting, meaning when you run out of memory, and the JVM crashes. Why is this useful? Well, it's useful for if you want to have some kind of thing to compare other garbage collectors against. Like, hey, this is the baseline. Nothing should be able to surpass this in performance. But also if you have like low running like short time running applications, not using any garbage collector might not be needed at all. Like, why deal with all the overhead of a garbage collector, even though the garbage collectors out there today have very little overhead, actually. But why deal with it at all if you just know that, hey, I'm just going to spin up a JVM, run for 5 seconds to parse some files, and then be done with it. Or if you know that, hey, I'm running an environment where I am completely in control of any single object allocated, so I know that I'm not generating any garbage at all, so why should I dedicate CPU time to actually running the garbage collector when I know there's no garbage to collect? These are the kind of things you could use the Epsilon GC for. One of the biggest things, of course, in the JDK11 that broke some of the backward compatibility was that it removed some of the Java E and corporate modules that were previously part of Java for a long time. And also, JDK9 actually saw one of the first experimental modules with the HTTP2 client or the HTTP client, and with Java 11, this client became a standard, meaning it was promoted from being an experimental feature to a fully fledged feature. JDK11 also added two garbage collectors. It also added the setGC, which is like a low latency garbage collector. A huge thing that JDK11 also did was it started deprecating stuff as well. With JDK9, they added support that, hey, we can deprecate stuff, and not just deprecate and saying that, hey, this is not going to be supported, but deprecate with the option to remove it in the future. And JDK11, we saw the removal of Java E and core module, which was part of this. And we also see they have, in JDK11, they deprecated the Nashorn JavaScript engine, which was basically the modern version of the scripting API that supported the new version of JavaScript, or EMCA scripts. And here they basically said, hey, we no longer want to support this, so let's deprecate it. And now they've actually reached to the point that the Nashorn engine is going to be removed from the OpenJDK from, I think the proposal is currently from Java 15 and on, it'll be gone. So again, you start seeing that the OpenJDK is starting to basically shred off some of the things that are either not used much or that is too complicated for the OpenJDK project itself to maintain. If we move on to JDK 12, which was released in March last year, we saw some further. We saw some of the changes that we saw another GC added. We saw the Shenandoah garbage collector, which was added by Red Hat, or primarily spearheaded by Red Hat. This is one of the garbage collectors that's actually a bit controversial in the sense that all the vendors out there that do OpenJDK builds based on Hotspot include the Shenandoah garbage collector, except Oracle. Oracle doesn't want to support this GC, so they do not include it in their build. So Oracle JDK does not include it, and also the OpenJDK builds available on OpenJDK.net, which Oracle is responsible for building, does not include this GC either. So if you want to use that, you need to download from a different vendor, for instance, Red Hat themselves, or adopt OpenJDK, or any of the other ones out there. JDK 12 also included one of the first preview features for language features, which was the switch expression, meaning the ability to use a switch block, both as an expression as well as a statement. So basically, the switch block, the switch expression can now yield a result. We also saw the code data share in CDS archives being now the default, meaning that the OpenJDK 12 was shipped with a pre-built archive of basically a lot of metadata about the classes that are in the system, so that they are a lot easier to git compile. Basically, store some of all the metadata about the classes in a file to make things start up faster and speed up. But they are specific to the individual environments, or more specifically to the individual operating systems and CPU architectures. So they are either generated on the first time, or they are shipped with specific distributions. So, and if you look at JDK 13, then we see that the JDK 13 further improves on this CDS archive architecture and added even more. They redid the switch expression preview language feature. They did a new iteration of it, and they also added a new language feature again, which were the text blocks, meaning multi-line text that also fixed some of the, to make it easier to have multi-line text in Java, which was previously you had to basically concatenate together, which didn't look that nice. So now we have a new syntax for it. They're in preview, meaning that you have to enable a flag both at compile time and at runtime. That means that the classes you compile can only be run with this specific major version of Java, meaning you cannot compile something with text block features on Java 13 and then run it with Java 14. They're not compatible in this sense because they're in preview, which is also some of the first times that, as I said, these are some of the things that the new modular system and the new release cadence allows to do, basically get things out a lot faster to the public to test out in the kernel preview, or, hey, this is done. Why wait 5 years to get it out when they can get it in 3 months instead? Of course, not all JEPs make it. There are a lot of JEPs out there that don't make it, that are canceled or scrapped for other reasons. For instance, one prominent was the language features for the raw string literal, which was later then changed into text blocks. The raw strings were originally slated for being released with the Java 12 as a preview feature, but was basically pulled last minute, just before the entire code freeze, because they realized that, hey, this was not the way it should be. So they basically pulled it out, went back to the drawing board, and then came up with the text blocks JEP instead. So, as I mentioned, we had these preview languages and VM features, or incubator modules. I mentioned the HTTP clients. There have been some few of them, and most of them have come in the recent versions. And I said these are there to basically give the developers and users of Java a chance to help develop these features, test them out, see how they work, if they need improvement. As mentioned, the switch expression went into Java 12 as a preview feature, and then it was updated in Java 13, and is now in Java 14, is coming in as a fully fledged feature, actually. And this is basically based on all the feedback that they gathered from users of it. They updated how it worked, so it became basically better. We have some incubator modules. We had the HTTP client, which is now part of Java. We have a few ones coming now in Java 14 as well. Language features as well. We've had the switch expression, which is going to be part of Java full-time now as well. We have text blocks that are still in preview. We have records coming in Java 14, which is also in preview. So this is basically trying to improve the feature, hopefully to a state where it's actually useful before it goes into become finalized and become a fully part of Java, or should it fail to not meet the standard, be removed and no harm done. Of course, there are some very big projects going on within OpenJDK. Some of the three big ones I would like to mention is, of course, Project Valhalla, which is value types, or as they're called today, inline classes. The ability to works like about basically having value types. So basically you have things that looks like a primitive but acts like a class. You have Project Loom, which is about like lightweight threads or fibers and continuation stuff like that. And you have Panama, which is about foreign function interfaces. We have already some indicators of those coming into some smaller JEPs from these already coming in that you can start playing around with. You have a incubator module coming in Java 14 from Panama, for instance, about foreign memory access. Another big project that has spawned a lot of the language updates is the Project Amber, which continuously do small improvements to language, sometimes also bigger ones, with switch expression, text blocks, and records all from Lambda, for instance. So these are some of the projects that there are, of course, many other projects going on within OpenJDK, just these, but these are just some that I wanted to highlight. And with that, I'm going to send it back to Justin for a bit.
Thanks, Michael, for all that detail. That's a lot of activity, and we've seen a lot of movement. And to do that, I just want to take a couple of minutes and sort of talk about the centralizing effect that all of this work through the JEP process has. So most of the JEP, well, really all of the JEP activity right now is centralized around the OpenJDK community. You can go to openjdk.java.net and you can look at the JEP process from there, which is actually JEP 0, and you can kind of continue your research and see what's going on. But you know, we looked at the statistics earlier on in the presentation about this widespread adoption of OpenJDK, and we know that, you know, there's all this activity happening upstream, and as a result, all of these JDKs that are being built by various vendors, and, you know, it's often kind of difficult to figure out, you know, which one should I be using? Is it Adopt? Is it the Red Hat build? Is it the IBM build? Is it the Azul Zulu build? And you know, as we said before, open source just sort of has this impact. It has this effect on software, right? People are going to branch, or they're going to find niche uses. I mean, I think Linux is probably the number one bit of evidence to support that notion of fragmentation. And I think really from a standpoint of choice and innovation, it's very much a good thing. But to counteract some of the confusion, I think, that can come out of fragmentation, and from that, some of the difficulties with adoption and standardization, the JEP process allows all of those different initiatives, all of those different people who may be thinking differently about OpenJDK or their applications from Java to kind of work from the same set of enhancements and work through the same enhancement proposal, so that regardless of, you know, which flavor of Java or OpenJDK, so to speak, they're deploying, which build they're deploying, or where, there's sort of a north star to all of Java's overarching development, which is the JEP process. So again, further fragmentation is likely to happen. You know, pointing out even that one of the biggest perpetrators of that fragmentation might be Oracle, when, you know, they are one of the few vendors of Java left that is still branching significantly from upstream with their build. But despite all of that, again, we really do expect Java and the language and the syntax and the standards and the process itself to remain a unifying sort of anchor across these various types of Java that we see deployed. And the process itself will continue to represent a central standard for which sort of all of Java is built upon. So I just wanted to make sure that we kind of drove home that point before turning it back over to Michael to tell us about what's happening in the future.
Yes, thank you. So as I mentioned already, Java 14 is just around the corner. So So what can we expect from it? Well, again, we have a lot of things going in. I already mentioned a few of them in the passing, but some of we have the first language feature that went through a preview phase, the switch expression going live or going standard, I would say, which is switch expression. We have the new record types, which is basically like syntax sugar in basics for data aggregator types, which is a long time coming because this is one of the biggest boilerplate code in Java at the moment. You see both Kotlin having already support for these kind of things, or if you're not using Kotlin, you're using Java, you can use something like Project Lombok to create all of this boilerplate for you, or some of the other tools out there. Your IDEs will also happily generate it for you, but if you don't want to see it in your code, then something like Lombok or the new record types could be of use. Again, there is actually a new language JEP coming in, the pattern matching for instance of, meaning this is for when you do instance of checks, then usually right after if X instance of string, right after that you would usually cast X to string because then you wanted to use it. The pattern matching, this JEP is basically a way to enhance language so the instance of check in itself can basically do that for you, which is quite convenient. You have a JEP here sponsored by SAP as well, which came from SAP's JVM. First SAP JVM, later SAP Machine, which is the helpful null point exceptions. Basically contain any developers probably seen a null point exception or two in their lives, probably a lot more. We all know that they're not very helpful as they are right now. It just says that something happens. That a null point exception happened, we will usually get a line in the exception, but actually when you have a long expression on that particular line, you don't know exactly which part of it was null. The helpful null point exception is basically here to combat that. Will tell you exactly which part of the expression was null, so which can be very helpful in debugging situations to find where things are going wrong. We also see another interesting, the concurrent marking street garbage collector is actually being removed, and also the parallel scams and serial old GCs also being deprecated. So we're seeing a lot of things that are happening on the GC scenes. You can also see the set GC for both Mac OS and Windows are suddenly coming to Java 14 as well. So a lot of things are happening on the garbage collector sides of things. A lot of things are happening on the language side of things, and a lot of things are also happening on the JVM. You see here that are the Java flight recorder event streaming, for instance. So you suddenly have an API for figuring out what's going on with getting basically flight recorder events streaming into your application, so you can actually parse them in real time if that's what you would like to do. These are all things that you might not think of as worth. Like if you're looking at the old way of doing things, release every 4 years, these were the kind of features that would kind of be swallowed by all the other bigger features coming out. So with this cadence, the new release cadence, you see these kind of features more upfront and center. You have smaller releases, but you actually know what each of these kind of things are that goes into releases. So that's one of the positive things I think about this new release cadence, is that there's a more focus on actually what goes in, instead of you seeing 100 things going in and then you focus on 5 of them. Here you might see 10, 15, and then you can actually go in and see that, oh, these are actually quite interesting things. These are quite beneficial to me or what we do for a living here. So I just wanted to kind of mention some of the big things that I've personally been testing or playing around with Java 14, which of course is the switch expressions. Well, these are most of the language. These are all the language changes going in Java 14. We have the switch expression going standard. We have the preview of the record types, and also the second preview of text blocks, where they kind of optimized a bit the way that escaping works within the text blocks. And then one of the first things from Project Pana, which is the foreign memory access API. which basically gives you a way to give you a well-defined API of accessing off-heap memory. So right now it's limited in the sense that you're limited to the memory you access yourself, but in the future you might see a way to access other processes' memory or share memory between processes and stuff like that, which is basically part of what Project Panama is all about. With that, I'm kind of concluding what we're going to see in Java 14, and then turn it over to you guys and see if you had any questions for us during these last 50 minutes.
Great. Thank you very much, Justin and Michael. We do have a couple minutes left here for some questions, and we had a few come in. Our first question was, what kind of impact has Oracle's license changes to LTS for Java had on JEP activity?
I can try to take that on. I don't necessarily see that the license changes had a huge impact on how the work on JEPs work. I think the change in the release cadence and the way we get access to the JEPs much faster has a much bigger impact. Also, Oracle is still one of the main contributors to anything that's happening in the OpenJDK. So I don't see their changing the license model having an effect on that. But just the whole way that the OpenJDK process and development works right now is just, yes, it has changed. Has changed for the better from an OpenJDK and development point of view. I think that's a yes. From an end user's point of view, that's still up for debate. Some will say, yes, this is way better. This is way better. We get access to all the new stuff really quickly. From people that are of more conservative nature and say that, oh no, things are changing too fast. Well, I can't really say, but I think the licensing changes from Oracle's point of view has not affected how the OpenJDK is developed itself.
All right. And then we have time for one more question. The next question says, where can I look for updates to be scheduled, to the scheduled work being done on Java?
Hey, so I'll kind of address that one. So we sort of just hinted at it before, that the JEP activity is owned and managed within the OpenJDK community now. So you can just go to openjdk.java.net/JEPs, JEPS, and you'll start at the index page, and from there you can continue to browse through. You can see the individual JEPs, and you can look at their activity. So I think really that, subscribing to the mailing lists, the developer lists, is a good idea anyway. So browse around, see what information is available to you. Remember that this is a community that anybody can participate in, and participation may just be read only. You may just come and subscribe to some of the lists and keep an eye on what's going on. But this is now the best source of information. Michael, do you have anything to add on that one?
No, I think this is one of the best sources of information. Of course, all of the major contributors to, or some of the major names within the JDK community, of course, also has their Twitter where they post all of this information as well. So following them on Twitter is also a neat source of information if you don't want to read 100 emails a day on the mailing lists.
All right, great, guys. Well, that's all we have time for today. If we didn't get to your question, we'll reach out to you via email. Don't forget to join us 2 weeks from today on March 27th for part 2 of our Java Renaissance webinar series, where we'll cover the OpenJDK adoption in 2020 and how it's impacting dependent technologies, how the OpenJDK release cycle is affecting the Java ecosystem, and the role OpenJDK will continue to play in the future of Java. Thank you, our audience, for your attendance and participation today, and a big thank you to our presenters, Justin Riak and Michael Rasmussen. I'll see you next week.